All right, hello everybody who is in here right now. I know this wasn't on the written program, but we have a special uh, demonstration here for you. I most certainly do not possess the engineering background to accurately describe what this is, but when we met Dan and heard about this project, we thought it was really cool. It really spoke to some of the innovative ways that people approach living, inhabiting, working in some of these potential environments in space in the future. So we are absolutely honored to have Dan here to tell us more about his project. There's an awesome demo up here, and I will turn it over to him.
Thanks, Patrick. Great to be here, and hope to speak to all of you after this and tell you a little bit more about this in person. So I'll be taking some questions at the end, but I'm just going to kind of brush through this now. So the idea here is human-based 3D construction printing. I worked on this with two engineering colleagues of mine, but primarily learned how to do this stuff on my own. It's kind of a labor of love, so I'd love to tell you a little bit about it. So the thesis here is that basically since early 2020, construction costs have risen by nearly a third, and 1/8 of the workforce has left the industry. That's changing a little bit now, but how does this affect the industry? So right now, there's been drastically increased adoption of 3D construction printing. So for those of you not familiar, it's basically just depositing cement or cementitious materials in very detailed ways that will basically be completely automatic. So here's some examples around the world. Icon in the US, Cobot in Denmark, and a project in Malawi, WASP in Italy. It's growing. And there's a lot of claimed savings, claimed labor savings, claimed time savings. But it's still in its infancy. There's a lot of work to be done. And the reasons, potentially, are long setup times, machinery that is massive, requires huge gantries, very complex and specialized interfaces, as well as requiring a very specialized operator who's spent years training how to use these large pieces of equipment, and because of the gantries, limitations in printing area. So what if we could do something a little bit better, right? It would be, can you guys hear me okay? All right, great. It would democratize 3D printing. It would make it more than just a novelty. You could build things more complex, faster, and cheaper, right? So how do we do that? We would need to create something that's quick to set up, that's mobile, it's easy to control, works independently, and is infinitely scalable. So on this project, which started out as a thesis, I originally spoke with a lot of people in the Brown community, in addition to a lot of NASA officials, space architects, spacesuit designers, tried to really understand my user base here. So we need to develop something for mass adoption with, it's got to be smaller, positionally aware, and have a really simple interface. Simple, right? So I originally started thinking about this uses in space, which is why we're all here today. And the original concept was, keeping it simple, go underground if you can to avoid radiation, and keep humans in the mix, because while these processes are intended to be automatic, as I said, this technology is in its infancy, and there's a lot that could and does go wrong. So as it was initially imagined, here's kind of the simple idea. And this would be mining either Martian or lunar regolith, combining it with sulfur, and creating a cementitious material that's easily deposited in a very detailed way. But a good colleague of mine told me perhaps we should get it to work on Earth first. So there's a lot of prototyping here. I'm just going to kind of blow through it, but please stop me if you have any questions. So after concept, a lot of different phases here, kind of looked at different auger types, control systems, material testing. So Michael Lai, who I think designed the next generation of spacesuits, he let me know that mobility is a really, really big issue with our current spacesuit. And basically, you have, even if you're a young, healthy person, you have the average mobility of an 85-year-old man. So did a lot of tests. And as you can see, just started with cardboard and wood. uh, and looked at different industries for inspiration. Because while extrusion is something that is currently possible, it never hurts to do a little exploring on your own. So plastic injection molding, welding guns, clay extruder heads, a lot of tests that didn't turn out so great. Ended up building custom sifters to get finer particles of concrete out of cement, and this does not look great either. But it works. Different control systems, different ways to kind of stand in. You want to be able to have your device understand when it's either approaching the ground or next to it. And then looking at different extrusion heads, different augers. So a pug clay mill is specifically designed to break up large clumps of material. And that's kind of the design I ended up going with here. So this guy's cute, right? But yeah, a lot of tests that didn't go super great, but a few that did. Again, this does not look beautiful, but it is technically a success, depositing cementitious materials on top of themselves. So here are some different examples with different compositions of fly ash, microballoons, plasticizer, chopped fiber, water. It's really quite the art. As a side note, I tested this with kind of duplicate Martian regolith and sulfur. So if you heat that to 150 degrees Celsius, it actually creates a compound that's really, really strong, like twice as strong as concrete. And this is an actual brick that I built and tested, and it is sturdy. So it's got to be flexible. So kind of from napkin cocktail sketch to actual working auger here. And while this doesn't, again, look super successful, it is the correct. This clump it's the closest I got to actually like depositing material correctly. But it's a success because it's the right dimensions and it's the right volume. So more importantly here, I think location tracking is kind of a big issue, and it's something that's really grown as a technology and kind of come into its own over the last 10 years with devices like the Oculus. So simultaneous localization and mapping, but there are so many kinds. Which kind? Very conveniently, the Oculus has inside-out computer vision, which is basically it's supposed to be accurate within 1 millimeter. It's cheap, it's easy to use, and it's the most convenient to utilize in this prototype. So that's what we've got going on here. So as you can see, it uses infrared, and the only downside here is that it doesn't work when it's too bright. So hopefully that won't be an issue today. So interface is starting to come along. Use Unity to develop something that actually tracks geometry in real time. There I am in the lab. So the original prototype called Spacious, kind of renamed it to something a little more democratic. That's my wife using this thing too, just kind of testing with users of different body types and different heights, weights. Developing a script to kind of turn the motor on and off. This is a little dry, so just stop me if it's a little bit too much. But long story short, it all ended up working, hacked together with a drill battery, a DC motor for a windshield wiper, and just some kind of off-the-shelf hardware. So control system was relatively simple, and at the end of the day, you move this device into the right location, where a structure is supposed to be, and it starts working, starts placing concrete. So that's what it looks like and how it works. But I'm not going to dwell on this because there I am building a wall that's not really there, but it could be. So this proceeded to a Rhode Island Space Grant Fellowship. And from there, I decided to focus on auto stabilization. So Michael Fisk, if any of you know this guy, he's great. I think he's kind of the gatekeeper to building structures on the moon and Mars over the next few years. Works at Jacobs with NASA, Marshall. So he thinks it could be an amazing repair tool, but it needs to be really foolproof. And I agree with him because it's not the most practical thing to to pick up and use for building a full-blown structure. So yeah, the goal here became to kind of integrate live feedback and reduce error and kind of be able to track global location in space, recognize the 3D print geometry in an augmented reality interface, and actively reorient that towards that geometry. And have that feedback loop kind of create like a real-time correction for imprecise human movements, right? So which feedback loop do we go with, and which motion? So here are some different kinds. Ended up going with the Delta configuration because it's the fastest, cheapest, best supported. It's pretty bulky, as you can see, but I think we can probably get that down quite a bit. But this is based around like an open source 3D printer. So technology like this doesn't have to be super expensive. It can be done with relatively off-the-shelf stuff. So again, feedback loop. Here it is kind of working in real time. So it's spitting out numbers based on the kind of like the video game program that I've developed. And so it's starting to come alive here, this feedback loop, but where it really gets interesting is here. So this is something I've also investigated just like for live painting in 3D, but it's kind of just a proof of concept that you can control a extrusion head real time with feedback from an AR device, which to my knowledge, I don't think has been done, but it was pretty cool to have around the house. And then, kind of expanding that nozzle quite a bit from 0.4 millimeters to like 2 inches. And then here's the Fisher Price version of the hardware. Gave it a nice paint job after that. This is going to be a lot heavier, so had to make sure that it would still work. And all in all, please don't look at my sandals. We've got our kind of hacked together boards and motion that actually works. So here is the new feedback loop. It is ridiculously complex. Definitely could be simplified, but at the end of the day, you get something that does this and actually orients towards the geometry in real time. So I'm going to very quickly do a live demo. A little more exciting, maybe. A second. Okay. So super easy to use, right? You got orient towards the geometry you're supposed to print. Yep. This sounds totally supposed to happen. Yeah, that's a general idea. So that can be refined, but it's just about 3 months worth of just me, stuff I learned to do. So the general idea is sound, and funding and development time, this could become something that actually.
This is a lapel mic that you can project a little more.
Oh yeah, sorry.
That'll help.
Yeah. Yeah, so it's not perfect. But long story short, it's something that is very simple to use, could potentially be very useful given the time and investment. But this is just reflecting a few months worth of work with a kind of a shoestring budget with off-the-shelf parts. So would love to develop this more. Question back? Sure. That sensor, I have it here. But the idea there is that it would prevent overprinting, right? So the auger, which does work, but just not today, it only turns on when it approaches the ground or the previous layer. So it's set at a height of 2 inches. So if it sees that, it's more than that, it won't work. The auger won't work. Yeah, no, it's totally just a stand-in. It's like a few $dollar part off the shelf. So, but you're right.
You can use anything that's distance and ranging LiDAR
Yeah.
with it.
Totally.
It work in the micro?
Yeah, it should. It actually should work much better because this is a little heavy here, but it would be a bit lighter up there. And just a few more points. So what this did successfully, so not a genuine PID system, but it does locate itself in space. It consistently identifies print geometry, reorients towards it, and live correcting for human error. So what I learned is that computer vision is freaking amazing, and we should all be using it for lots of projects. Location-based extrusion, I believe, will work. However, I think mass adoption on Earth, maybe not so much. It's pretty heavy. But as a hybrid repair tool, could be pretty useful. So I'm trying to get together with NASA Marshall and develop a can. And maybe something like this could happen, right? It's you've got an autonomous vehicle that goes around printing things, and then you need to make a repair. You can just kind of snap off the arm and connect it back up to the vehicle, which itself is producing the cementitious material. And got some happy astronauts here. So, but yeah, I'd love to take some questions if you guys have. Hey.
So you mentioned based on open source, and then as well that it was part of was a PhD or a thesis?
Yeah.
So I'm curious, did you go through your academic tech transfer office to secure any IP? Are you doing open source distribution? What's the kind of plan path forward?
I should be, but I'm doing this all in good faith. So, yeah. Yeah, if we have time for one more question. All right. Great. Thank you very much. Awesome to be here.